Hi guys, Eric Enielli again. Today I got Ronnie's PT Cruiser. He's actually the guy that built this garage years ago. He had a body shop in here. He was my neighbor growing up and everything. Showed me a lot of things about working on cars. That's why it's so much like nostalgia even being back in this garage. This is where I used to come to Mooch Tools and see if he could fix a dent in my car and something I hit, anything. But he has a PT Cruiser. It's a 2004, and it's making a lot of noise in the front, like where the timing belt goes. We did order a new timing belt and water pump for it, but I'm hearing some noise coming from like the intake runner. They have them butterfly valves in there. It's supposed to help you on a cold start, help you pollute a little bit less anyways. But I'm hearing the sounds on like the driver's side of the engine even further away. I'll let you hear it. It's pretty loud, but I was going to get cam and crank, the correlation with them. I don't know what scope I was going to use yet. I was thinking maybe the Habtek or something, but it's getting pretty late. But I'm just playing around, so maybe I'll get it tonight, maybe I'll get it tomorrow. But I just want to show you a way that whenever I'm looking at a wiring diagram or anything, I did get the all data, the 1 month subscription for it. It's like 19 bucks, and there's promo codes out there, but it's pretty good. It's what I do is I go to, this is just the the crankshaft position sensor, and it's pretty easy to navigate to. It's, I recommend this. There's a lot out there. Ivan, he has like the free. It's great for specifications. It's great for a lot of things, but sometimes like this, if it's not mine, I'm to be as professional as I can be, and hey, you charge them $20 extra for hundreds of dollars worth of information for 1 month. But it's very easy to get to, like whenever you do have a month subscription. If you wanted something like where we're powertrain management, computers and control systems, and we want the crankshaft position sensor. Then you get the description and operation. I'm not sure if that's what I'm on here. Okay, that's just where it is. The PCM uses the crankshaft position sensor to calculate the following: engine RPM, TDC number 1 and 4, ignition coil synchronization, injector synchronization, camshaft to crankshaft misalignment, timing belt skipped 1 tooth or more, diagnostic trouble code. Now we do have an engine light on. I didn't even plug it in yet to scan it. I just wanted to see if the cam's really making all this noise or if we're off teeth, but I'm going to plug it in before I do anything. But I basically wanted to just get my setup, get the cam and crank, look at the known good that's on all data, and just see if it's in time, see if something skipped. But the way it starts, I know an RC test is coming too. That should be the first thing when you hear something start like that. But being some already plugged in there, damn it, I'm going to get the cam and crank while I'm there, because it takes a while to get to it. But here's the description. Like, the PCM sends approximately 5 volts to the Hall effect sensor, so that tells us it's a Hall effect. The voltage required to operate the Hall effect chip and the electronics inside the sensor. The ground for the sensor is provided through the sensor return circuit. The input to the PCM occurs on the 5 volt output reference circuit that operates as follows. The Hall effect sensor contains a powerful magnet. As the magnetic field passes over the dense portion of the counterweight, the 5 volt signal is pulled to ground, 0.3 volts, through a transistor in the sensor. So that tells us if we're looking at something that's not quite at 0, it's supposed to be 0.3. This isn't pulling it the whole way to ground. I notice sometimes when I would look at a waveform, or even whenever I watch one on YouTube, it's not going the whole way down. And you start thinking, is it a ground problem? Well, in this case, it wouldn't be, as long as you're not over, 0.3 volts. When the magnetic field passes over the notches in the crankshaft counterweight, the magnetic field turns off the transistor in the sensor, causing the PCM to register the 5 volt signal. The PCM identifies crankshaft position by registering the change from 5 to 0 volts, as signaled by the crankshaft position sensor. So this is what we should see. These are the teeth, and we see there's one that got one long one up here. So we should expect to see, what I'm guessing anyways, it might be the opposite, but one long tooth and several small tooth. If they go with the cylinder, it don't look like, it looks like there's more in between. The PCM determines what cylinder, well, if I'd kept reading, I answered my own question there. It determines what cylinder to fire from the crankshaft position sensor and the camshaft position sensor input. Camshaft. The number 8 crankshaft counterweight has a target ring with 32 teeth and notches, including one long reference tooth and a notch. From the crankshaft position sensor input, the PCM determines the engine speed and the crankshaft angle position. So that's a lot of information. Now we know with the 32 teeth. Some of these that you do, like the last one, I don't even know what it was, Chevy Trax, Equinox, something like that. Each tooth was, there would be 2 teeth between number 2, 3 teeth between number 3, and they're not all like that. This is a 32 tooth, so we know we're not probably going to be able to figure out anything except where more than likely number 1 is, you know, on its crank. But what I do before I get out the scope, like a multi-channel scope, that's what this little U-scope is very handy for. Because, well, there goes my light flashing, but the wiring harness in there, it tells you the color, and I went after the color that it'll show you. Anytime you're anywhere on this crankshaft, you could go back and look at the description in the operation or the diagrams, and that tells us the crank signal except the 1.6. This is a 2.4, so except the 1.6, that would be us. It's a gray wire with a black stripe. It was that easy. There would be the back of the crankshaft position sensor, but we can't get to that. That's underneath a plate that goes under the starter. That's why I'm probing the harness where it was already, you know, heat cracked and open. Easiest spot you could get to, go for it. And it's sometimes the computer's easy going to the ECM, but these are still taped up nice. They got nice grommets. So I just went where, took the air box out and went where a nice open stretch of harness was. But I'll let you hear what this sounds like. Let me grab the camera real quick and I'll focus it on the U-scope, because this is where I'll get the crank sensor, and I'll leave that wire piercing probe there. I know I got the crank sensor. Now I'll move on to the cam, check it with the U-scope. Then I know I have 2 good connections. Move on to a multi-channel scope. All right, guys, I'll let you hear what it sounds like, and I'll show you what the crank signal looks like on the U-scope. See what it was talking about with the big tooth. Did they say that? Just for the hell of it. I mean, it doesn't. I'll actually stop it. Let's stop it. You can zoom in on it if you want to, but I'm not really looking for anything now but a signal. As I press on it, you could hear the sound change. But I'm hearing something very loud under here. Yeah, she sounds lovely, right, guys? See, that's what I was looking in the back. I was actually looking at this right here. This, I believe, is the cam sensor, but I thought it was on some of these, there's a passage, and they just have a butterfly in the intake. This doesn't even have that, so I thought maybe that was one of its, you know, better hopes that that sound's making noise over here. Because, I mean, I'm hearing pretty loud noise. It might be displaced, but and I'm definitely going to do an RC test on this too, make sure. I don't like the way when you turn a key, there's that, you know, no compression in one hole sound. But we're gonna check it out. But first, we're gonna make sure if the belt jumped or not. All right, guys, let's move back over to the tablet, and let's went to the powertrain management, of course. Powertrain management, sensors and switches again. Camshaft position sensor. The diagrams, locations. Let's see the connector views. What color wire would we be looking for? There's the connector view, and we're looking for tan and yellow. That's the accept 1.6. Okay. Well, that's what we just did. We looked at that. We could see number 3 is the camshaft position sensor. So we go look for the tan and yellow wire. All right, that's an easy one. There's 3 wires are exposed, and we're looking for tan and yellow. That's tan with the yellow stripe right there. So that's us. I'm going to get another wire piercing probe into that, or if I could back probe it easily. This looks like one of the connectors. It might be rough, so I'm going to just go ahead and use the wire piercer. And that battery, this thing needs a whole charging test, an RC test, everything. I'd hate to go ahead with a timing belt whenever it's making that kind of noise. Maybe the water pump snapped loose. I know the tensioners go on these, so it seems like too much noise for over here. Okay, guys, if you could hear me, this is the tan and yellow, and the ground is just going to the strut tower. Now we know we got the cam and the crank. Getting a good signal on it. So go a little bit more time. Alright, guys. Alright, now that I have a wire piercer in both the cam and the crank, I think I'm going to get, I could reach this still has spark plug wires, and looks like it goes into like a waste spark coil, but I could pick up at number 1, but I'll need 3 channels, so it's either Modus or the Habtek. Everybody's, I mean, seeing what they could do with this Habtek, and I mean, I know it's good for cam and crank. I've never used it on that, so I'm going to give it a shot. I mean, these things are, everybody got one of these, that it's usually one of your first scopes. So see, guys, I like being this far, as I always say, I like being this far away from the car, because the car's here, I'm over here, everything that, you know, could get sucked in the hood. I use just that little U-scope. That's easy to control under the hood, find your signal, and then you could go on. In this case, we're going to use the Habtek, but, you know, I like being away from the car. I don't like having my things laying on the car, on the hood. I mean, the heat, I know with the camera, with the bore scope, heat's a factor with it. I mean, how much is it hurting your scope laying on top of that heat? So just keep it packed, make it nice, enjoyable, relaxing. This is a chair I found in the alley back there. I usually pull right up to this and just take my time, you know, this is fun. You guys out there doing this for flat rate, you're out there making money, feeding your family, that's great. You have to do it fast. You know, me, I'm just taking my sweet old time. I enjoy doing this. I no longer do it for, you know, cash. I'm not doing this steady. I do this, it's pretty steady because I enjoy it. It's like I'm doing my hobby steady, put it that way. But I mean, this is all interesting. A lot of it's new to me, so it's still got that flair, and it's been there for a while. That, you know, I'm not getting tired of it. I really like this. I'm really interested in it. I just keep going, and it's, you know, that's kind of what makes it fun. I'm not on the clock. Like if you're working on your own vehicle, you're not trying to beat any time. You're just, you know, turning the nuts and bolts and hearing that relaxing click of the ratchet. But at any rate, before you do anything with any scope, well, yes, with the Habtek, you just clamp the two together, and you don't have to go to the Habtek calibration. I just go to the hscope calibration. The calibration, 0 level, continue. That easy. Make sure you do that, because I've taken voltage measurements and it'll be off, like with the voltmeter, it was off 3 volts because I didn't calibrate it for a while, but after I calibrated, dead on. But alright guys, I'm gonna flip that around. I'm gonna show you closer to the screen. I'm gonna connect both them channels and see what we get on hscope. Alright guys, there's a setup there. There's a shut tower bolt for each of them. Now I'll turn the volume down. Now I'm going to set you up here. And now this is just oscilloscope mode. We should see something. Alright, that's just channel 1. Channel 2. There's channel 2. Now see, this is all we have with 1008C. We have a 2.4 volt scale and a 19 volt scale. This scope really isn't at home here, but it's doing the job quite fine. It's, if we had something a little bit closer to 5 volt would be, you know, that would right be in its native. But, having said that, I'm going to just, I like my lines a little bit thicker, a little bit easier to line them up. Kilosamples. Now we can only go up to 2 without going into pages. Alright. We're going to go most time we can put on. Okay, what we're going to do now is we're going to go to automotive. Your sample right here, that's going to be very limited also. 20 milliseconds of division, that's a good start. Hit record. We're not getting the kind of signals we want to get here. That's really clipping them. So even if we go up to 9, we're locked at 2 now. Any more and we'll go into page mode. We really don't want to do that right now, but we could see our signals. To look at these multiple different ways, and this is going to be easy to line that up with a known good. So what we're going to do right now This is just the cam and the crank. Okay, I was probably just blabbing to myself. I don't know if you could hear me over the engine, but as you increase the resolution, you have to enter pages mode. This is the highest resolution without entering page mode, with 2 channels going. But this is good enough for us to line up the cam and crank. Now, there is a known good that Chrysler gives you on the all data subscription, so we're going to compare it with that and see if we could tell what's off. But first, I just want to put another channel on, see if we could pick up number 1's secondary ignition. All right, guys, all I did over here is I put the HT25 around the number 1 spark plug wire, and I just put the ground on the strut tower again. This thing got some pretty well grounded struts, so I'm using that to see if we could pick up ignition signal so we could sync it up if we ever had to, because if you got 3 channels, if you got more than 2, may as well use them. But from the factory, now this is going to help you later, like if you ever had any problems or if you ever needed to compare it. But the cam and crank correlation on the factory data is just the cam and the intake, or the crank and the intake cam, which is, I believe, the only cam sensor on this car. But if you have an exhaust cam sensor, some of them do have the 3, so you'd need the 3 channels. We could have did this with the 2, but being as we're using the Habtek, we're just going ahead and, you know, picking up an ignition with it. Just seeing how good the scope does on it, that's all. All right, guys, I probably should wear hearing protection running this car, but I mean, one more time. Here we go. I'm seeing ignition. Filling that buffer up. We have 15 minutes we could record this at. Usually on those Habteks, you don't have that. This is all hscope right here. Looks like we do have some ignitions. That's what we want. I'm afraid to give us a little gas, but we'll see how it tracks. I know that's not much of a snap, but you could hear it. I'd say, yeah, we pulled in really good. I mean, you're not going to analyze the ignition with this, but you are going to be able to sync where the firing event is. I believe we need an invert on it. But you could see it as we go, the definition, you do lose definition the more you add. The more channels that you add, the more definition that you lose. Okay, here we go. We could still see where it's getting pulled down the ground. We could still see the firing line. The burn line, not much. Good, not in 10 milliseconds. See how some of the lines start getting dotty and choppy. It's just about all the harder you can push these guys. You're not gonna We could change with the eyeball, we could change what we're looking at, which way we're looking at it, but you're still going to see a lot more dots than you want to see. Because whenever we added the channel, and if you go down, the closer you look, the more dots you get. But can you compare the big crank signals? Absolutely. Can you see where the firing event is? Yeah, pretty close. I mean, I don't know what kind of accuracy that can give you. It can give you some, because I mean, you could see the lead tooth that we're looking at. And that was the highest we could go before entering pages. Pages, you will get some more definition, but you're not going to be on the same page. You might be able to catch a whole event on one page, but you know, it's hit or miss. As we go, I'll show you pages once with, we'll go up to 4 seconds, or 4 kilosamples a second, which is a little bit more, but we are going to enter page mode. Okay, stop it, and as we go back, you see the definition will get better. Oh, let me put it on full screen. Sometimes it's easier with your fingers to move it around like that. Now we see a little more definition even in the ignition. So, but you see what I mean as we enter pages. On this, it wouldn't, you'd be better off going on pages because you could get a whole event on one page. The more definition you go, the smaller the pages get, but you do get more definition. I'll demonstrate that also, because it's a hard concept to understand unless you're actually doing it. Now this is 9. The white ones are all page mode. The more definition you have, the shorter the pages get. So we'll do it one more time on this. Okay, we'll stop that. We'll go back. And you see how short the pages get from here to here. But we do have more definition even on the firing line. But you see the definition of the cam and crank increases greatly. But you might not be able to get your whole signal on there. So the obvious are what I do or would do on this one. With the one we got at just the cam and the crank, oops, I'm sorry. The one we have a gist of the cam and the crank, that's going to be the one we want. This is what we should have. And what I'm looking for on this one, okay, the cam sensor should be when there's 3 teeth, one on the crank lines up with the first tooth. That's something that obviously stands out to me. And that would be after the long pause. And one thing to take note too is which way these are facing. The last time, I believe it was on the Nissan Juke, I had to flip them around, just invert them. But you want to make sure you're looking at a signal that's got the right, you know, let's just call it polarity for lack of a better word. So we want to make sure that the cam sensor or the crank sensor long tooth is facing upwards. Let's see, a long tooth facing upward on the cam. Actually, I want to separate these a little more. Okay, here's the long tooth. On the cam, the green trace here is a long tooth, and then these two look like they almost lined up. I thought, there we go. We have the long tooth on the cam here, and then the next one lined up with this tooth almost. Almost, I mean by eye, almost perfect. We just want to make sure. Here we go again. This one is the long tooth, and then the very next one was lining up with that one. We could see it's a little bit to the left, and if you were using, you could still probably count teeth pretty accurately. Well, I won't say accurate, but it takes some of the V away, so you could tell which one how many teeth you're counting. And this one is almost directly aligned, but it's a little bit to the left. Let's see if what our known good looks like. That would be this one here. Let me make sure one more time. That would be the crank on a down. That's the crank on an up. Unless it needs inverted, that's cranks on an up, cranks on a down. I know it's a hell of a way to line them up, but I mean, there's always a way. Like this would want to, channel 1 looks like it does need inverted. Just to make sure. That this is what we're looking at in the middle. You could count the teeth along the edge of a straight edge, but right now I'm just, you know, by eye, it's looking like that thing's off a tooth or maybe more, but looking at that known good, this crank signal should be a little bit more to the left and lined up in between these two. But you can make an overlay. You could do whatever you gotta, you know, come up with to find which way that your waveform's looking compared to that waveform. Because you could look on, I hear Martin's starting a waveform library on the cloud, or Martin's cloud, that he's starting a waveform library. That's, you could get ones from hscope that would be already able to load in hscope, and you could compare this whenever you're comparing off of like a factory book like that, or an image. You could put this in Paint. I'm not on the laptop right now, but Paint's really good on the laptop. You could put lines on them, almost make your own rollers. You can make an overlay, you know, an overlay of a known good like this on hscope would be, you know, an excellent tool. But for right now, that's kind of how I line them up, and I'd say that would be enough for me to say that timing's off a little bit. You know, I don't know how many teeth, maybe 2, maybe 1. Seems a little bit more than 1 to move it that far down. But right here's what I'm comparing, because it sticks out. You could count the teeth, but this sticks out. I look for things like that that stick out, and then you find them on your waveform. The next tooth after the long one, we're here. And it's not lining up in the middle. All right, guys, that's a quick wrap up on that. I just wanted to get a signal on it, just see if it is out of time. So that starting could be out of time, but it sounds like, you know, it's twisting like something doesn't have enough compression. But I'm going to do an RC test on it, and, you know, just look around a little bit more before I say, you know, timing belt's going to fix this. All right, guys, that was some interesting and very loud waveforms, and with that amount of information compared to the known good waveform, if that was the only sound it was making, I'd definitely go ahead and change the timing belt, water pump, get it back on the road. But I'm hearing a little bit more noise than the front, so I'm going to take a little bit better look on it before I make the call and just go ahead and change the belt. He might be getting into something else he might not, you know, want to get into right now. But if it's out of time, the RC isn't going to be very valid, and it's going to sound like that when it starts. You know, it's going to buck. But, you know, there's something else in there, and I'm going to take a little bit better look at it. But if you're into PT cruisers or just into the oscilloscope, we're going to be using it a lot. You know, we're going to be changing the time, and we're going to get the before and after. Tomorrow, being I already got the wire piercing probes attached, I'm probably going to hook up the Modus, just get one good capture with it at a cam and crank so I could see a little bit better, a little bit more definition, and we'll go from there. All right, guys, thanks a lot for watching. Adios. Hey, guys, it's another day. I was over at my parents' doing some landscaping work for them, but now I got back. I wanted to do a couple more tests on this car, and I did a little bit of research, and I read on all day a lot of things about this engine, and, you know, none of them are good. It's but I just wanted to share with you first. It only has a PO 113 intake air temperature high. Now that's because I have that disconnected to get in there. Now this is my friend, my neighbor's car. If I was in the garage, I mean, I wouldn't even know what to do at this point, because what I'm going to do, because this is, you know, my neighbor, I want to get a better image of that cam crank correlation, because according to the service data, if this belt was off 2 teeth, it would set a code, and that's the only code. And I know, I mean, you guys watch Paul Danner whenever he said that there's always an exception. I hope this thing, like, yeah, PT cruisers do not eliminate like 9 hidden codes if you disconnect the air intake, but I'm going to be all right with that. But it's not throwing that code. It's not throwing nothing else in that. If that engine's only off 1 tooth, this engine, that's needs more than a timing chain. But what I read, it was a lot of, there's a chain also behind the timing belt, behind the bracket on the oil pump. And a lot of people just delete that chain. They cut the chain. And these have bad lifters. So, and, you know, a lot of time the tensioner on the timing belt makes a lot of racket. That we could fill. That we could prove. But, I mean, the bottom line is, I mean, I know you know, get excited, you want to do the timing belt or something like that, and it'll be like, okay, you know, this was another garage. I mean, that's why I really didn't even plug it in. They told them it needed a timing chain. We got a timing chain, the water pump. But, you know, after hearing it, you know, it was, I could hear it whenever he was driving around, but it wasn't quite this loud. They told him it was okay to drive it around for a while, because they told him it had a timing chain. Then, got it inspected, and they referred him to another garage, but you know, he asked if I did timing chains. I mean, yeah, of course. I mean, they're one of the funner things to do, actually, in an engine, because you're not really yanking everyone out. Some people like to yank engines out. I really don't mind getting chains on anything, but, you know, it's just fun. But at any rate, we don't know what else is wrong with it. Going to prove that the timing's off with a better scope. I was going to use a Modus, but actually, I mean, I'm only using 2 channels. I'm going to use the 512. I forgot about it yesterday. It gets really accurate images, and yeah, plus it's hscope. It's, yeah, pinch to zoom. But what I'm going to recommend is we put the timing belt on, because if this thing's out, definitely it looked like it was out at least one tooth yesterday. Even an RC test isn't even what you're going to do if it's out of time. Of course, it's going to look different. It's going to sound different. This thing sounds like it's out of time. This thing had a distributor, I'd be turning it, yeah. But it doesn't. It has a computer, and it's, you know, it's definitely, I'm kind of thinking almost every test we got, like, you know, with the oscilloscope, the biggest thing we could do is prove that it's out of time and move on from there. So if you were selling this to somebody, I mean, you know, I'm going to just be honest with them and tell them, you know, that I don't think that's all that's wrong with this engine. Could be something in the head, could be something that's chained, but the direction's different. That changing the timing belt has nothing to do. You don't even take off the rocker cover, so you don't get a good look at the lifters. I mean, they got roller rockers on top of all that. I mean, I don't know, but runs pretty good, and only got 70,000 on it. But I mean, if it's that chain slapping, a lot of people live with it. They say that, you know, they put 100,000 miles on it with that noise. So it's kind of like a question: if you could prove it was off like that, what else could you use scope wise? I mean, the transducer. I mean, that ain't, you know, you're not going to be checking anything engine mechanical, not with it out of time. That's where I'd start anyway. That's what I think I'm going to do, unless, you know, I hear some better ideas. If one of you guys got a better idea than that, let me know, and we'll use the scope and see if we could find a pulse sensor. I mean, could see if it has a blown head gasket. I mean, that would have nothing to do with that sound, but it would be like, yeah, if you got a blown head gasket and you need a timing chain, I mean, that had got to come off anyway. So maybe the pulse sensor. And definitely the camera. If I could get that #1 plug, I'll take it out and, you know, just take a visual inspection of the inside of the engine. Just give them a little guidance before we get too far, you know. But once you do get on the gas on this, pulled around the garage, it makes a racket, but it does move pretty good. And that balance chain, some people take the balance shaft out, some people just cut the chain. You know, I don't know. I think he'll live with the noise for as little driving as he does. All right, I'm going to hook up the 512 and, you know, just get that cam crank correlation, just so I could say, you know, that Habtek, man, it was like playing connect the dots. All right, guys, I did, even though this came from another garage, I figured I'd check the oil, check the antifreeze. It's filled with both, and it's clean oil, so I was thinking maybe, you know, checking the head gasket or something like that, but that's definitely not that noise. So what I'm going to do is just the same thing I was going to do, get the cam crank correlation, just prove it's out of time, and we definitely know just by, you know, visual and hearing inspection that there's something loose under that front cover. Just I hear something over here too, and I just mentioned it before because this is like, you know, Ronnie, I'll tell him straight up, this is, you know, this is going to definitely help the engine get it back in time. Then I'll be able to find out what else is making the noise. But that balance shaft, that's kind of weird. Yeah, I mean, I don't know about deleting it. The engine shakes a little bit more, but, you know, I think in this case, it'd probably say cut it, but cut it or deal with the sound. I don't think even failure of it damages anything. So they're just letting the balance shaft spin in there and the gear. And there was even a video guy tore it apart, tapped out the oil, returned. I mean, excellent video. I mean, just to take off the gear because it adds to the rotating mass of the engine. Well, Ronnie's not going to care about the rotating mass of a 2.4. You know, he's having Impella SS's, so it's, you know, he ain't worried about drag racing a PT Cruiser. So if it comes to cutting that chain in the future, we have to do that from underneath. You know, if it comes to something in the head, you know, even to do a tune-up, you have to take off the upper intake. Maybe out would be the next thing, so I could take a little bit better look in there after it's in time. Right now, we're going to just prove it's out of time. All right, guys, I literally just moved the leads from that scope to that scope and got hscope back up, oscilloscope mode. I'm going to start this and kick on the exhaust fan and remember how loud this thing is. You see I'm walking around a good bit too at idle. That's getting on more where we are. Pretty good image here. I'm happy with it. I don't think we need to go up any more than 75. 75's good, 20 millisecond. Okay. Still got you on 3.3. Oh, flipping away. We're only talking out of 2 volts. Yeah, we're going back down to 3.3. Then we got 12 minutes and 48 seconds of that. That's more than enough. I'm going to shut this off before it's split. I want to save what I got here. I'll name it later. But it's what I was comparing to yesterday. I know there was one set that lined up on the known good, and I believe it would be this tooth right. Maybe not. Because it was after, oh yeah, it was after the long tooth on the cam sensor. The very next one, this crank sensor's right in the middle of it. We could look here, I mean, it's a hair off, even with a ruler, it's a hair off further than this big crank signal after the cam signal. And I'll put it back up there again. I'm sure it's closed up by now. That was yesterday, but on all data they had the known good waveform, and that's the part that, you know, maybe that's one tooth off and it didn't set a code, but it definitely doesn't look like the known good. All right, guys, I'll switch to the screen recorder, make this a little bit easier. Well, I'm lining. This is the crank sensor. When it's facing down, the long tooth on the cam sensor, the very next upward one. This is the same way I set up the waveform. I'm using this line as a straight edge, and the whole crank sensor is inside of the cam trigger. So when I switched yesterday, it really looked like it wasn't in there, but this would be the same. We have the one tooth, the one long tooth, the very next upper one. I'll watch you later. Okay, we got one long one, the very next upper one. This is it. It should be a little bit more to the left, but wow, that's maybe a tooth. But what I wanted to see too is the repetition. Does it stay that even? Because it was just idling the whole time. We weren't giving it no gas or anything like that. No snaps. See, it's a little bit more inside. We'll go to the next one. this is what I'm looking at right here. On our waveform, this was completely inside on the known good. But it's not very. We're going down just to the next cycle. Now look, this would be a little bit out of the cam. So yeah, it's moving some. But man, now that I heard that plastic sound, I'm thinking more mechanical. Something under that. Something under the rocker cover. You can see we're splitting down. If I put this right on the yellow one, cover up the yellow line together, we're outside of this event. And the closer you zoom in, the more you could see that we're completely outside of the green of the cam. And it wasn't just another revolution ago. And we'll just we'll pick a random revolution down here. Because all we're doing is finding the long green one here, the next cylinder. Now look how far this one moved. Nope, it's going to do a lot of measuring for me, but because I forgot to move just that other roller, but we're just using it for a straight edge. Same thing, we're going to cover. Now we could measure the difference, but this is pretty obvious that this is bigger than what we were just looking at. We could actually see the black. So yes, well, the easiest way, whenever, like this, if I wanted the other roller, I could go back and find it, or just flick these off the screen with your finger. Well, it usually works. There we go. And then just drop some new one. I went way back to where the first one was. I only got rid of the one. But okay, you see what I mean. We could just use it for a straight edge. You could even see it without a straight edge here, that the crank signal's shooting off air. So it's walking around. It's actually moving. That would be here. Now we see it's closer. Then towards the beginning, there were some that it was the whole way inside, and I was starting to rethink, like here. If we dropped another one, again, don't mind the measurements, but if we put one right on this yellow, cover the yellow line, we could still see green on the outside of the pink, so it's moving the whole way in. So yeah, one of them's walking around, that's for sure. And on a belt-driven car, I mean, if it skipped a tooth, that should still be pretty, repeat itself in the same position. Maybe the loudest part of that sound, maybe that's that tensioner blown to pieces, but that happens too. That's the problem with these engines. There's so many major things, and like usually on timing chain, you're taking off the valve pan cover anyways. On this, you don't. So you have to take off the upper part of the intake to get to the valve. So you're going another direction. To get to this balance chain, you have to drop the oil pan and go that way. We don't have to do that for a timing belt. That's kind of nice. If the rest of the engine was sounding good, it's great that you don't have to do all that to get a timing belt on it. But when you got questions like this, that you're not going to be just passing anyways to take a good look at it. But what I think, after thinking about it for a couple minutes now, I was thinking like an RC test wasn't going to be any good. But this thing doesn't, if it's only out a tooth, this thing sounds like it's out a lot more than a tooth. This thing doesn't say this, it sounds tight, like almost like two cylinders are compressing, like if there was a restriction and you were getting two compressions at once, or one, it doesn't sound like it's spinning too easy. It sounds like it's dying. So, I mean, we're going to see if an RC test does have any value to 0.2 which cylinder, I'll sync right off. I still have that Habtek HT25 plug clipped on number 1. So to do an RC test, I mean, I can even do it with battery voltage right off of the, I don't even need to get out the amp clamp. So that's going to be in next direction, guys. Battery doesn't have much left in it for but what I want to do is move this up to 20 millisecond, go with the 20-20 rule again. Pete, what is it, Pete Meir. It's 20-20 rule. I forgot his name in the last video, but I mean, his rule always comes to mind. Okay, so what I'm going to do is just start it and see if I get a pattern. Do we see anything on the voltage? It did run though. It wanted to. That battery definitely isn't too good. What I'm going to do is make this. If you hit the button, you have a couple seconds where you can manipulate this. Make it bigger or smaller. I'm going to put a filter on it, but we want to mark number 1 like that. Now we have no filter on it. See what a low pass does to it. Oop, I put on high pass. Yeah, we still see our event or spike there. That's all we're really looking for, but I think it was a little bit better without the filter. At least we could see which cylinder was what. We're going to go with none and just deal with the noise of the Habtek. Can't get it back to the no filter point. I think I ran into this before where I saved it, reopened it, and then I was able to, nope, it saved it with the filter on. At any rate, we're going to just expand these just so we could tell which cylinders. Number 1. Looks like it is a waste spark, or it's firing twice. It's individual coil wire, so I doubt it would be picking up the other one, but the main thing is what we can tell. I do want to look into the description and operation of the ignition, because I believe it's firing twice, but the humps are all fairly in line. On channel 1, we should be able to get more use out of a filter. Even at 1,000, that's good. That's the way it sounds cranking. Very confusing, but we could see too. Well, it's not so much confusing the ignition, because I mean, we've seen that before. Even what I'm going to assume that is a wave spark just by the way the coil looks. But even if that's interference from another cylinder, what we're looking at is these compression peaks. They're even. There's two, only unless, I mean, if we're completely missing two humps, I mean, and there's supposed to be four here, then I mean, it's up the creek without a paddle, but you'd think that would look a lot worse. So I guess for right now, before I just make an assumption that is wave spark, I'm going to look into the description operation of the ignition. Because if it's not firing, let me put this right, it would be firing every 360 degrees, but to a different cylinder. It'd fire, I'd assume 1 and 4 at the same time, and 2 and 3 at the same time, possibly. Or if I read that description and it's only firing once, you know, we're missing 2. I mean, the way it sounds bad. It sounds cranky. I mean, tell me you guys that thought it was gonna, towards the end there, I mean, even if you heard the way it sounded, even though it tried to start here in the beginning, I mean, you heard the way it sounded. It wasn't good. You wouldn't expect it all even humps like that, even if you drop a roller on top of them. That's dead on. Man, see, that's why you don't get things in your head. I was thinking busted rocker right away, you know, because, but man, if there was a rocker off on it, one of them humps wouldn't be at all. All right, so move on to the next step and figure out what that sound is. I mean, we know the timing's off a little bit. Maybe it's that tensioner doing all that rattling. Sure doesn't sound like it to me. Being that little bit out of time, I mean, wouldn't make it sound like that starting? That's a question. Okay, guys, I looked it up. The high tension leads route to each cylinder from the coil. The coil fires 2 spark plugs every power stroke. One plug is a cylinder under compression. The other cylinder fires on the exhaust stroke. Coil number 1 fires cylinders 1 and 4. Coil number 2 fires cylinders 2 and 3. The PCM determines which of the coils to charge and fire at the correct time. So, you know, we kind of figured that's what it was going to be. But whenever you hear something sound like that, you know, don't make a mistake. You know, but just from what I've seen in here, if you had a cylinder dropping the whole way out, you'd be missing one of these humps altogether. You know, this hump just wouldn't be there and would have, you know, either firing line or no firing line, but would be able to tell what cylinder. But right now, all we could tell is one of these is cylinder 1 and one of these is cylinder 4. Each firing event could be 1 or 4. Being these humps are equal, I mean, it doesn't warrant going in. Like you could pull a plug, you could loosen, or just loosen the plug a little bit. You could pull a spark plug wire a little bit. Well, that's not going to do you much good. Loosen the plug and you'll see a dip in one of them. And, you know, you could tell which one. If you took out number 1 and you see a dip and a firing event, you know that's it. This part right here won't be as high. It'll be lower. So it's back to pointing all towards the timing chain, but I mean, that's really good news for Ronnie anyways. You know, that's what I like to see, especially your French cars. You hate to tell them, you know, that you ain't got no compression in a cylinder and you think, you know, that there's going to be big problems. But all right, we're going to go on to the next step. We're going to keep testing this thing until, you know, I'm a little bit more positive about putting a chain on, or a belt on it. All right, guys, I hear the church bell, so I'm going to call it quits for the night. But we seen what the RC test looked like quick when the battery was going, and tried to run a little bit. But you could all hear the sound I was talking about, the way it's cranking like that. Sound, you know, something's bonding something. But I was thinking maybe a broken rocker or something like that. But using the scope, at least we were able to save taking off the top of the intake and taking off the rocker cover beings for a chain and a tension, or a belt and a tensioner rather. We're we're not going that way. It doesn't sound like a metallic sound, so, you know, I don't recommend dropping the oil pan to check that balance chain because it's not metallic like that. So I'm going to just go for a chain. I hope that tensioner just grenaded in there, and that's what's the sound just radiating out here through the, you know, the firewall, and it's just tricking these old ears. But, you know, I know without the scope, I would have taken off that upper intake. The way it sounds plastic, I mean, you'd even think maybe the cam sensor was broke, but we're getting a great signal off of it. But I would have taken this off and the rocker cover just hearing that plastic. But if it's radiating around the back where that tensioner is, maybe it's shaking the whole machine like that and tricking me. But at any rate, you know, I'm not putting a timing belt on something with no compression or that has slip so bad to the point that I don't believe these can hit the valve. I believe it's a non-interference engine, but we'll learn a little bit as we go. I mean, the coils, it's just DIS ignition, same almost like Wave Spark. It's firing on the exhaust too. So that's why we see every car you do, you see something a little bit different the way they do it. And then whenever you see it again, you're like, oh yeah, that, you know, that's how it goes. But it's always good. I mean, always good to look up the description and operation. This I was kind of bouncing from, you know, because everything I was testing, you know, fairly decent. So I was going around and I didn't really read the description and operation first of everything I was looking at, but I could tell by the looks of their coils that they're not, you know, there's not a coil for every cylinder, or it's not a single shared coil. All right, guys, I mean, any ideas, anything that you would do next? I mean, you see the equipment I have, even if you have better equipment or if you have no equipment, it all works the same way. If you've watched Scanner Danner and you remember something that I don't, I mean, even if it's something obvious you see me overlooking, definitely drop me a comment. Means a lot, guys. All right, thanks a lot for watching. Adios.